wrong one. Okay, so today we are going to record today's weather, work on the problem of the day, do weather day 7 about fronts, and then there's a quizzes at the end, and then math workshops if we get a chance. You should all be in Canvas and have yours open, yes? Yes? Y'all are following along? Okay. Okay, you are unmuting and talking. You need to raise your hand first. All right. So, this is my weather tracker. Camera on, please. I'm making notes of those who have their cameras off so that I'm sending emails. Because your cameras need to be on. Okay, so I need the high-low, the wind speed. You would think I'd have this memorized. Air pressure, humidity, rain, and prediction. Oh my goodness. All right. I am opening up my weather bug. There's my weather bug. I tell you what, it takes time for these computers to warm up. All right, high 70, low 60 today. Wind speed is south 10 miles per hour. Air pressure is 30.05. Humidity is 91%. That goes down through the day. We have 0 rain and prediction. Unless the wind changes directions throughout the day, I think it is going to continue to warm up for the next couple of days, maybe just tomorrow. All right, so now I'm going to go back to my weather tracker. I am going to enter this information in. Today is the 3rd. High-low is 70 and 60. It is going to be beautiful today. The wind is out of the south at 10 miles per hour, which tells me it is going to continue to warm up. Air pressure is 30.05. Humidity is 91%. We've had no rain. And because the wind is out of the south, I believe it will be a little warmer tomorrow. One of these days, I'm going to learn how to type without hitting all these other letters. That would be nice too, huh? All right, so do you see how quickly it took me to do that? So as quickly as it took me to do that, you should be done with it by now too, right? Because I've told you what I do is I write down the information that I need, and then I'm not going back and forth. I write it all down, then I go enter it in. It just goes a whole lot faster. If I'm going back and forth, it takes forever, right? Takes forever. So you should be done. No lie, you should be. Because we've been doing this for a few days. You should have kind of figured out your system by now. And I try to help you out by giving you a system. But because I'm nice, I'm going to give you 1 more minute to get it done. Set a timer for 1 minute.
Okay, 1 minute and counting.
All right. So I am done with this. I am going to go back to our assignment for today. Our weather tracker is done. So I want you to make sure you click Submit, Save As, because we're not submitting it yet. Click Submit, Save As, and go open up Day 7 and your notes, okay? Let me show you. I say let me show you. Let me get my Canvas open so I can show you what I'm talking about for those of you who do not understand. So when you go on Canvas to open up the stuff for today, I'm going to go click on Modules. You have the weather tracking that you just did and closed. You have today's POD notes and quizzes activity. Some of it's from yesterday. And then you have your weather, air mass, and front notes. So I want you to open up this Science, February 3rd, 2021, and Science, weather, air mass, and front notes. Because we are going to continue with these front notes as we are going through the presentation. Okay, so let me repeat that again. You need to open up Science, February 3rd, 2021, under week 22, and open up the Science, weather, air mass, and front notes. Let me say that 1 more time because I promise you somebody is not listening. Open up Science, February 3rd, 2021, weather day 7, and Science, weather, air mass, and front notes. Weather, air mass, and front notes. Nod your head no if you are not able to find it. Shake your head no if you are not there. Okay, nobody is shaking their head, so we all have it open. Give me a thumbs up. Okay, fantastic. Providing your services no matter where you're at, period. You are appreciated, period. All right. Okay, so let's get to today's learning objectives. I leave all of those on for us, but today we are just going to focus on fronts. We are going to focus. Correct. So I am going to underline the question. And then I'm going to enter in what before I even get to answering the, before I even get to the multiple choice, and I'm sure some of you have scrolled down to the next one and looked, I need to write down what I know about the sun and the wind, right? So what do we remember about the sun and the wind? And you should have written it down yesterday or typed it into your notes yesterday, right? So if you look back at your notes yesterday, one of them tells you what happens. One of them tells you what happens. I'm going to give y'all a minute to figure it out. Read through your stuff from yesterday. No? It's in your notes. It's in your notes. The wind moves from west to east. There's more to that sentence if you're looking at your notes. The wind moves from west to east. Are y'all looking?
The wind moves from west to east due to the uneven heating of the earth.
You are absolutely correct. That's it. Thank you, ma'am. How many of you are looking at your notes going, oh yeah! Yeah, it was on there, wasn't it? Yep. It was on there. So now that we know the wind moves from west to east due to the uneven heating of the earth, have all this. Let me animate. I want to copy this. Now, we can select an answer, right? Now we can select an answer. Raise your hand if you will read A for me. It is in the Canvas assignment, okay? So you can close this Cami file, but make sure that when we are done with notes, you go back into it and do the quiz is. Not right now. Not right now. If I go look at your Go Guardian and you are doing the quiz is right now, I'm shutting it off. You need to be following along with the notes. Thumbs up. All right. You need to have your notes open, not the meeting. Your notes need to be open. Scarlett. You do have the notes. You just have to go open the file in Cami. Those notes. Yeah, those notes. They're fill in the blank. So I will read it to you and you're going to fill in the blank. Okay? Okay. All right. Let's review a couple of things from yesterday. On your notes, you should have what is air mass. The very first box says, what is air mass? Air mass is a huge bubble of air that has similar temperature, moisture, and air pressure. Air mass is a huge bubble of air that has similar temperature, moisture, and air pressure. You should have these already filled in from yesterday. Thumbs up. We did this yesterday. So you were either, if you don't have them filled in, you were either absent or not paying attention. Do you understand? I'm not going to wait on you today. If you were absent, you can go back and you can catch up. If you weren't paying attention, that's your responsibility to make sure you get it done. How are air masses classified? Well, scientists look at humidity, And temperature, that's not working. Let me fix that. Science, look at temperature and humidity. All right, let's see if that works now. Scientists look at temperature and humidity. What? It worked. Okay. So air masses are classified based on their temperature and their humidity. Okay, just switch pages. All right. In North America, the air masses usually move from... Right, I see some of you saying it. Yes, it moves from west to east. It moves from west to east. Prevailing westerlies. So this all happens because of the prevailing westerlies, which we will talk about what that is. And remember, we wrote this down yesterday too. Yes? You should have these notes completed as well. We'll get to that in just a second for a review. It also is caused by a jet stream, which is a really fast stream of air between the cold and the warm fronts. And it just kind of goes all over the place. But it always moves from west to east. Now, that's way up there in the atmosphere. What we feel down here closer to the earth where we're at, the first 6 to 7 feet, maybe even 10 feet, the wind can blow in all sorts of different directions. But that's because of the uneven heating of the earth. And it's also because we have buildings and trees and things that get in the way, right? So the wind sometimes goes around it. And then you have cold fronts and warm fronts and occluded and stationary fronts that really affect what happened to us on a day-to-day basis right here within the first 10 feet of our atmosphere. Prevailing westerlies are winds. They are global winds. So that's like a big spectrum. They are global winds that blow from west to east due to the uneven heating of the Earth's surface because of the Earth's rotation. So you got a bunch of things that involve the global winds. The prevailing westerlies on the global spectrum, like it goes all the way around, right? They move from west to east because of the uneven heating of the earth and because of the earth's rotations. They are approximately located 30 to 60 degrees latitude. So that's like above the equator. How do the jet streams affect the air masses? They are fast, super duper fast, 110 to 225 mile per hour winds way up there that we don't ever feel. And that pushes along the air mass. So it's just way up there. It's not in our 10 feet where we feel things, right? Your notes should have this information. So, there it goes. Your notes should say that major global winds, so prevailing westerlies, are major global winds that move from west to east due to uneven heating of the Earth's surface. Uneven heating of the Earth's surface, okay? The jet streams are fast-moving air currents that push along air masses. So I'm going to move this one up. There we go. All right. So your notes, because we did this yesterday, guys. We did this yesterday. Your notes for prevailing westerlies should say that it is major global winds that move from west to east due to the uneven heating of the earth. And man, I see some of you guys reading it along with me. That is fantastic. You know what that tells me? You're going to remember it. You will remember it and you will be successful. That is amazing. Thank you so much. If I could give you a high five through the screen, I would. High five for saying it with me. The jet stream. Let's look at the jet stream and remember what a jet stream is. The jet stream is fast moving air, like 110 to 225 mile an hour air way up there. They are currents that push along the air masses, okay? They push along the air masses, like the high air masses and the low air masses, and then our fronts, which we are going to get to. So let's move on to what is a weather front. We're going to watch the short little video. We've already seen it, but it's just a great reminder. It's stationary fronts, and we will dig in a little bit deeper with those. All right. So are y'all ready to listen again and start filling out your notes? Nope. Nope. Nope, not that. All right. So just real quick, this is already, if you look above that bottom table in your notes, if you're looking just above it, there is a sentence that says, air front is a boundary where air masses meet. Okay? What we are going to do is we are going to draw the symbol of the front, describe it, and explain resulting weather. It says you can use the draw tool or insert a Google image of the front symbol. So, the first one we are going to talk about is cold front. Okay? There's 4 types. There's cold front, warm front, occluded front, and stationary front. We're going to talk about the cold front first. Are you looking at your notes right now? Everybody's looking at your notes. You're going to be filling in your notes while I'm saying this, okay? And I'll say it a couple of times. You ready? What is a cold front? And be prepared to answer that question out loud here in a minute, because you know me, I like to ask it and you answer it. So, cold fronts are rapidly moving air masses that run into warm air masses and push it out of the way. The cold, dense air sinks and pushes the warm air upward. The weather it causes are clouds, rain, snow, or thunderstorms followed by clear skies. Okay, so your notes. Now, if you look, what I want you to do is I want you to put an X through where it says boundaries are to blank air. That's not right. That's not right. So you're going to have to type in a whole sentence. So I want you to add a text box over that definition for a cold front, okay? You're going to add a text box over just that definition of a cold front. And you are going to explain that a cold front is a boundary where colder, drier air pushes up and out the warm, moist air. If you need to know what the sentence looks like, you can come back to the meeting and look and then go type it in, but I will say it again. The cold front, the definition that they had in these notes was not correct, so I'm changing it. The cold front is a boundary where cold, drier air pushes up and out the warm, moist air. I will say it again so that you can get it. A cold front. A cold front is a boundary where cold, drier air pushes up and out the warm, moist air. Wave at me if you need me to say it again. I got a couple people. All right, I'm going to say it again. A cold front is a boundary where cold, drier air pushes up and out the warm, moist air. All right, I am going to go back and I want to read the type of weather. The type of weather it produces is clouds, rain, snow, or thunderstorms followed by clear skies. So the weather it produces is cloud, rain, snow, or thunderstorms followed by clearer skies. I will read that again. Cloud, rain, snow, or thunderstorms are followed by clearer skies. So when a cold front moves in, it creates a massive disturbance that brings us heavy, loud rain and snow, thunderstorms, and then as it pushes past, you get clearer skies. In Texas, there is a time period in the spring where our storms can get pretty bad. Have you ever went outside and watched a storm passing where it's really dark gray and green on the front end and it's very clear on the back end? Have y'all ever seen that? That's what a cold front is. So we get a lot of colder air that pushes through in Texas, and the fronts are ugly and dark, and you can literally look out west and see the clear skies past it. It's crazy. Actually, no, warm fronts occur when warm air overtakes a cold air mass. The warm air pushes over the cold air because it is not strong enough to go under the cold air. Now, it does say it goes over the cold air, but as it's going over it, it's pushing it out, okay? So the warm front is going over it, but it's still pushing it out. The weather is heavy precipitation over short periods of time. Sometimes hail or tornadoes occur. Now, in Texas, you never know when you're going to get bad weather. Things change all the time, and it does actually any state. But the idea is that with warm fronts, the weather is not as severe as with cold fronts, right? In the springtime, our cold fronts are a little bit heavier. They're a little bit more drastic. But warm fronts are a little bit lighter. It might bring some light rain for short periods of time. So, again, a warm front occurs when warm air overtakes a cold air mass. The warm air pushes over the cold air, causing it because it is not strong enough to go under the cold air, and it causes heavy precipitation over short periods of time. So, warm air meets. Okay, so are we looking at our notes? We ready to fill it in? So, for a warm front, the warm air meets a cold air mass and pushes over the cold air. Did y'all get that? So in your notes, it says the warm air meets the cold air mass and pushes over the cold air. Now, as it's pushing over it, it's still pushing it out of the way, right? Because it's a little bit stronger, but not strong enough to push under the cold air because heat rises. Are you with me? So, the definition of a warm front is the warm air meets the cold air mass and pushes over the cold air. The weather that it gives, or what happens is heavy rains. Oh, warmer air is not strong enough. Okay, so it's heavy rain over short periods of time. So it's brief. Hail or tornadoes are possible. But I have a note down here. It is not likely to cause major thunderstorms like cold fronts. So even though it can cause hail and tornadoes, it's not as major as cold fronts. Cold fronts have a bigger impact than warm fronts, okay? So let's read that again. Warm fronts are warm air meets cold air mass and pushes over the cold air. And then you have heavy rain over short periods of time where hail or tornadoes are possible. All right? All right. And then we'll move on to the occluded. Occluded fronts occur when warm air gets caught between two cold air masses. Between two. So warm air gets squished in between two. The warm air is forced over the cold air, and then more cold air pushes it again and again and again. The weather that we get is temperatures get cooler. It might bring rain or snow, but afterwards you get cool, dry weather, right? It's cool and clear and beautiful. So let me read that again, and then we'll go to our notes. The occluded front occurs when warm air gets caught in between two cool air masses. The warm air is forced over the cold air, and then more cold air pushes it again. The weather is temperatures get cooler, and it might bring some rain or snow, and afterwards it is cool, clear weather. So, the occluded front. Y'all ready to type it in? The occluded front is warm air is caught between what? Two. I see y'all saying it. Yeah. The warm air gets caught between two cold or cool air masses, right? The temperature gets colder. The temperature gets colder. I see y'all saying it. Man, that's fantastic. The temperature gets colder. You might have rain or snow. Maybe. It's not likely, but you might have rain or snow, but the temperature is always cooler and clear. Okay? So occluded is warm air gets squished in between two cold air masses. The temperature gets cooler. You get rain or snow possible, and then the temperature is cooler and clearer afterwards. So as the front is moving in, you get things that happen because it just disturbs the air and creates all kinds of issues. And then as it moves past, you have the cooler, clear weather. Ready to move on to the stationary front? No, I have some people still typing. I'll give you a second. All right, now are we ready to move on? Yeah? Okay. Good deal. We're going to skip that part. What is a stationary front? Stationary fronts occur as warm air mass and cold air mass, they meet. And usually the temperature difference between the two masses is so little that neither one is strong enough to move the other. So they just kind of sit still, right? So the weather may result in a lot of precipitation over several days, causing flooding because the front is so slow, right? It's such a very slow moving front. So let's fill in our notes. So you will kind of have homework tonight. The quizzes is going to be homework because we didn't get a chance to get to it, okay? But I am going to ask that you go do the quizzes for homework tonight, okay? All right, let's finish our notes. The stationary front. The stationary front. Oh, we also need to draw them. We'll do that maybe tomorrow. Maybe we can draw it in tomorrow. The stationary front is warm and cold air masses meet, but neither one of them are very strong. So it's kind of like when you push your hands together, it's the same strength, and neither one of them is going to push the other one out of the way. So they move really slow. And so you get rain or snow over several days. Here in Texas, well, in North Texas, we're likely to get lots of rain for several days, and it will cause lots of flooding, right? All right. tomorrow we will take a minute to go ahead and draw in those fronts in our notes unless you want to do it today. It is actually on here that you can draw them in. Oh, wait, go back. It's on the slides if you want to draw them in. Cold fronts have triangles, warm fronts have circles, stationaries have circles and triangles opposite of each other, and then occluded have a rotating pattern. You can see that. So if you want to finish that today, that's fine. If not, we'll do it tomorrow. Otherwise, go ahead and click Submit Save As on your notes. Go do the quiz tonight. Don't do it while you are in math class. That ain't cool. Maybe do it during lunch or specials or something and get it over with, right? And then I will see you guys back here at 2:25.